Hello, we are going to start our new unit, Unit 4, which is going to be covering equations, functions, and inequalities. So today what we're going to do is we're going to talk about equations using just one variable. These should be kind of familiar to you. Essentially what we're doing is just story problems and writing equations from those story problems. So it shouldn't be anything too new, but I know it's usually not everyone's favorite to do story problems. So story problems, though, are important to know because that really is the reason why we learn math, is to know how to apply it. I know sometimes the examples or questions I give you seem silly, but learning how to actually apply the math that you're learning is kind of the whole point. So you'll also use equations or story problems like this a lot on the ACT. There's several questions that come up where you have to come up with equations and solve them. So this is really good practice for the ACT as well. But whenever you run across any kind of story problem, it's important to do these things in this box right here. First, you want to identify what you know. These are going to be things like maybe numbers they give you, units they give you, equations, things like that. Then determine what you're trying to find. Usually that's going to be in the last sentence of the story problem. They'll tell you what to look for. And then this one I think is really important, is to draw a picture to help you visualize the situation. You don't have to be an artist or anything, doesn't have to be fancy, but some kind of sketch to kind of help you organize all of the information you get is extremely helpful. And then you want to find familiar formulas that will help you. I say familiar because these should be equations that you know, and if you don't know them, they're going to give them to you. So they'll either give you the equation or it's going to be a familiar formula, like area of a square, something like that. And then also always check your answer for reasonableness. That means, like, does your answer actually make sense? If you're finding the area of a square and you get a negative number, that doesn't make sense. You can't have a negative area. So sometimes you can know that you did it wrong just by making sure your answer makes sense or not. And then always make sure you answer the entire question. Sometimes there might be more than one part, and I'll have students do the first part and then they're just going too fast and they forget to answer the rest. And then always use the appropriate units. So I'm going to show you a few different types of story problems that you'll run into. So let's get going. Okay, this first example says you want to create a custom border for a picture of you and your closest friends. The picture measures 5 by 7 inches. What should the width of the border be if the final area, including the border, is twice the area of the picture? So familiar, or identifying what we know. They gave us this 5 by 7, and they also told us that we are going to do an area that is twice the area of the original picture. So that's something that is important. Also, they gave us the fact that we're using an area. We're going to use that to know what formula to use. Because again, we want to try and find a familiar formula. If I have a rectangle here, a familiar formula for the area of a rectangle is area equals length times width. So that's going to be our familiar formula. And then we are just going to start putting together everything we know. And I already have kind of a picture sketched here for us, but our original photo was 5 inches by 7 inches, and then we're adding some border that is X inches wide. We know that the total area of the new rectangle, including the border, including the original photo, is twice as big as this picture. So because they told us that, we know that the full area is going to be twice as big as this area. We can find the area of the picture because we know its dimensions. We can do 5 times 7 for length times width. So the area here is 35 inches squared. So my total area, including the frame, has to be twice that big. So if I do 35 times 2 equals 70. So I know that's what I want my area to equal. My area has to equal 70 times my length and then my width. So here's where we have to come up with an equation. We know the original photo is 5 inches across, but we're adding a border on this piece that's X big and X big. So to write the equation for this piece, we're going to do 5 plus the 2 corners, which is 5 plus 2x, or 2x plus 5. And then same for the height. Originally it's 7 inches, but we're adding this length here, an x plus 7 inches plus another x. So 7 plus 2 x's, or 2 corners. So these are going to be our length and our width. So we're going to take those two pieces and plug them into our familiar formula. So we'll have 5 plus 2x and 7 plus 2x. Again, you could flip it and do 2x plus 5 if you wanted. But now that we have our formula set up, we're just needing to solve. They're asking us to find how wide should that border be. So essentially we're solving for how big should x be in order to get an area of 70 total. So to do that, first we're going to have to FOIL this guy. We're going to do 5 times 7 is 35. 5 plus 2x is 10x. 2x times 7 is 14x. And then 2x times 2x is 4x squared. And then we can combine some like terms here, and I'm going to put it in descending order. So I'm going to do the 4x squared first. 10x plus 14x is 24x. And then we have that plus 35. We still have this 70 just coming down. So remember, whenever we solve quadratics, which is an x squared and an x, this trinomial type format, we have to have 0 on one side first. So this 70 can't be here. So before we start solving, we need to minus 70 over first so that we get this 0 on the left side. And then we have the 24x, and then 35 minus 70 is negative 35. So from here, you have two options. You could solve this by factoring by hand. When you factor by hand, though, it does take a long time, and I'm not necessarily testing you guys on factoring right now. So you could use your calculator instead, which is what I would do, especially if you are on the ACT and your whole goal is to go as fast as possible. What we're going to do is graph and find the x-intercepts, because the x-intercepts, that is where we equal 0, because we're 0 at the x-axis. So that's going to be our first thing. If you don't have a graphing calculator, you can always use Desmos.com or the app Desmos on your phone. And it works really well. I actually think it works better than a graphing calculator. But we're going to just go in, let me clear out all this old stuff, and type in this equation so that we have 4x squared plus 24x minus 35, and then graph it. My window's kind of big, it looks like. Let's fix my window. And then essentially we're just trying to find where we equal 0, which is at the x-axis. So let me zoom in. So we see we cross two different times here, but we can't have two solutions for the width of x. If we think, again, if our answer makes sense, if it's reasonable, this is a negative answer right here. Does it make sense for my picture frame to be negative inches wide? No. So I'm going to throw that answer out because it doesn't make sense. We only need that positive answer. So again, to find this x-intercept, you're not just going to guess. In your graphing calculator, you're going to push second and then go to the calc menu. And then we're finding the zeros. Remember, 0 is just a synonym for x-intercept. And you'll see it says left bound. You might have to find, there's a little dot. So find your little dot. There's my dot. Right now it's saying it wants you to be left of the intercept. So think of it kind of this way. Right now we're to the left and down of it. We're going to push enter. And then we're going to go right bound. I'm actually going to go one past that. And then it says to guess. This is the closest it lets me go because we're at such a steep line that when I go over once, see how far it jumps. So I'm going to use this one as my guess, kind of as like my middle. So you're kind of going left, right, and guess, and then it tells you what that 0 is. So that x value is how big our picture frame should be. So x equals 1.21 about. And so that is your answer. And that is going to be a lot faster than trying to solve by hand, especially since we got a decimal here. That means it didn't factor evenly. So we probably would have had to do like quadratic formula, which takes a long time. So just kind of keep that in mind. You can, if they're not testing you on factoring, you can always graph and find your answer that way, especially on the ACT. Okay, let's do another one. The height of a plastic storage container, or a plastic rectangular prism storage container, is 4 inches shorter than the width. The length is 7 inches longer than the width. The volume of the storage container is 5,304 cubic inches. What are the dimensions of the container? I see questions like this every time on the ACT where they give you your equation in sentence form. So you have to be able to translate this sentence into an equation. So we know we're dealing with essentially a big box, right? A nice rectangular prism storage container, as they like to say. They've told us that the height of this is 4 inches shorter than the width. So that means h, our height, is whatever the width is, but 4 inches shorter. So I'm going to write that as width, w, minus 4. Then they told us that the length is 7 inches longer than the width. So L equals whatever the width is, but then it's 7 inches longer, so we're going to add 7 to it. And then the width, we don't know what the width is. So the width just equals W. We don't really know what it is. But they've told us that we have the volume. The volume equals 5,304. So for our familiar formula, we're obviously talking about volume. They've given us that keyword there. And we're doing it for the volume of a box. So volume equals length times width times height. We know what the volume should be equal to. They've told us it's this number. So I'm going to plug that in. 5,304 equals my length, which I have as W plus 7. I'm going to plug that in. Times my width. I don't know what W is. We're just going to keep it as a W. And then my height, which is W minus 4. And notice how the only variable we have is just W's. They've given us the height and length in terms of W. So we don't have any H's or L's in here. It's all now just W's. So I'm going to go ahead and FOIL this really quick. I wish I'd put the W on the outside. I'm actually going to FOIL the two binomials first. So W times W is W squared, and then minus 4W plus 7W, and then 7 times negative 4 is a negative 28. But then all of that is being times by this little W out here. So if we times that W through, and we can use also combine our like terms here. W times W squared is W cubed. And then we had negative 4W plus 7W is 3W. But then when we times W into that, we get a 3W squared and then minus 28. But just like the last example, before we can solve for W, we need to have 0 over here. We always want it to be equal to 0. So I'm going to minus that number over, so that we have a lovely 0 on this side. And then we have W cubed plus 3W squared, and then negative 28 minus 5,304 is a negative 5,332. And again, you could waste your time factoring here, but the faster way just to be put it into your graphing calculator. So I'm going to put it into the graphing calculator. And again, we're going to see where the x-intercept is, where we equal 0. So grab your calculator out. And I just realized I forgot to put the W onto this 28. So that actually, we can't combine those two. So this should be a minus 28W minus 5,304. So my bad. So again, I'm going to just graph this to save time and rather than factor. So grab your graphing calculator out. You don't have to use W's either. We can just use X's to plug it in, just because that's a little bit easier. So I'm just going to do X cubed instead of W cubed plus 3X squared minus 28X and then minus 5,304. And then let's graph that. We might have to zoom out on this one because it's kind of a big graph. Yep, so nothing is showing up in my intervals. Remember, I'm going from negative 10 to 10 and negative 10 to 10 on the y's. So let's zoom out. Let's just do negative 20 to 20. So again, I just went to my window here and I'm just making my x min and max going from negative 20 to 20. And let's do the y min and y max from negative 20 to 20. Let's see if that will show it. Sometimes you have to play around with the window. And that's another reason why I prefer Desmos, is because you can just scroll in and out with your fingers, which is way faster. So we have one intercept here. There's probably more because this is a cubic. So remember, a cubic makes kind of that swirly shape. So it might be going in 2 to 3 times. We could zoom out and find more. But again, we need to think of reasonableness. We wouldn't take any negative answers because that wouldn't make sense for the width. And then our box can only be so big. So my guess is anything much bigger wouldn't make sense because we wouldn't get the right dimensions on our box. So I'm thinking this one's probably the only answer that would work anyways. So we're going to go and get that 0. Oops, there's the wrong button. Go to second, calc, and then 0. And again, we're going to go left, right, and guess. This is a really straight line, so we might not be able to see our little dot for a minute. See if we can find it. This is where I need the awkward elevator music to play. And I can't even see it. Okay, so we're gonna have to zoom out more. You can also go to the zoom button and zoom out. Let's see if we can see it this way. So second, calc. Oh, there's our little dot. Let's go back to finding our 0. See if we can see the dot. Goodness, it's not wanting to show up, is it? Okay, we're going to change our window again. Let's go from 0 to 20 because I don't really care about the negatives. Let's see if we can zoom in on here and see maybe it's going right through something. It does look like it's going right through. So this is 20, 19, 18, 17. Our width is going to be 17. And then here's a good example of a problem where you need to make sure to finish. A lot of people are like, oh, got my width at 17. But they wanted all of the dimensions. That means they want the length, the width, and the height for your answer. So we've only found the 17 inches here. So we need to find the length and the height, but that's going to be easy because we have these little equations. We just need to take the 17 and plug it back in. So our height is going to be 17 minus 4, which is 13 inches. And our length is going to be 17 plus 7, which is 24 inches. And that would be your final answer. So just make sure to plug those in to your H and L to get all of the answers. So again, if you don't have a graphing calculator, you can always go to desmos.com or the app. I almost think it's easier because you don't have to like mess around with the window like I was to get the right dimensions. Okay, we're going to do 2 more types of problems. The first type we're going to look at is work problems. These are going to be problems where you have like 2 people working on the same job, but they work at different rates kind of thing. So whenever you have problems like this, you're going to use this equation. You want to consider this a familiar formula now, so maybe memorize it. I do see ones like this on the ACT. But you get T over A plus T over B equals 1, where A is the amount of time for person A to do the work by themselves, and B is the amount of time it takes the second person to do the job alone, and then T is the total time if they were both working together on the job. So, and then it equals 1. So a good way to kind of remember it is think of this fraction as being the portion person 1 does of the work, and then this is the portion person 2 does of the work. And together, if you do person 1 plus person 2, you get 1 job done. So 1 whole job. So that helps me to remember that this is a 1 over here. But let's see how this works. So on this example, it says Britton can refinish the floor in 9 hours. Britton and Jason can refinish the floor together in 4 hours. So how long would it take Jason to do the floor by himself? So you're always going to be finding one of the 3 options. Either T, A, or B will be your missing variable. So it looks... On this one, we have Britton can refinish the floor in 9 hours. That's going to be A. He's person 1. And then they tell us Britton and Jason together can do it in 4 hours. Since it's together, that's going to be T. So we are trying to figure out how long it takes Jason to do it by himself. That equals B. That's what we're trying to find. So we're going to take these numbers and just plug it into our equation right here. So T was 4. So I have T over A plus T over B equals 1. So I'm going to have 4 for T over A, which is 9, plus 4 again for T over B, equals 1. And this is a rational. That's why we did our rational unit. It's kind of an easier rational, but we're solving for b down here in the denominator. So whenever we're trying to solve a rational like this, we want to get our least common denominator, our LCD, which for this one, you can think of this as being over 1. Doesn't really do much, but we have 9 and b. So our LCD will just be 9b. We're going to take that and times that through to all of the different parts. And then that process will get rid of our fractions, which will make it easier to solve. So this 9 will cancel with the 9 in the bottom, and I'm left with b times 4, which is 4b. On this fraction, the b's cancel, and I'm left with 9 times 4, which is 36. And then 9 times b is just 9b. And then that's a much easier equation to solve than this one with the fractions. So we love to do that. This is a b, not a 6. We want to combine our b's together. Let's minus this 4b over. I'm going to write it over here. So those cancel, and we're left with 36 equals 9b minus 4b, which is 5b. And then solving for b, let's divide by 5. And so I would probably get a decimal here just because we are talking in time, and most people don't say, oh, it took 36/5 of an hour. So if I do 36 divided by 5, that gives me 7.2 equals b. So we would say 7.2 hours. That's how long it would take Jason to do the floors by himself if he didn't have Britton helping him. Okay, so that is the work problems. And then the next type we're going to look at, this will be our last one, are problems that have to do with distance, rate, and time. So these are specifically ones where you're going one way and then coming back. So you're doing something going there and back again. It's really similar to kind of how the work problem is set up, where you have distance over rate 1 plus distance over rate 2 equals time. So you have those two fractions again. D is going to be your distance one way, so not round trip. Sometimes that can be a mistake that students make. And then R1 and R2 are going to be the rates there and the rates back. And then T is the total time traveled. So this would be round trip, how much time it takes to go round trip. So let's look at this example. It says a tugboat goes 12 miles per hour in still water. It travels 45 miles upstream and then 45 miles back. So that's the distance one way. So that's going to be our D. And then in 8 hours, that's the total time there and back. So that's going to be T. What is the speed of the current? So here's kind of the tricky part in here. They're telling us this tugboat goes 12 miles per hour in still water. So it'd be like a lake, nothing with a current. But it is going up a stream and back. So a stream or a river does have a current going down the river and back the river. So let's say here's my little river, okay? Let's say this is the direction it's going. When our little boat is going down the river, okay, that current is making it go faster than what it would do. So when it's going downstream, it's going to go that 12 miles per hour, however fast the engine is pushing it, plus whatever the current is pushing along. But then let's say now I'm going up the stream. So I'm going against the current. So when I'm going up the stream, I'm trying to go 12 miles per hour, but that water is pushing against my boat. So it's slowing me down. So I'm going to have a speed of 12 minus c, depending on which direction I'm going, down or up the river. These are going to be our rates. So it doesn't matter which one you do, but let's say this is rate 1 and this is rate 2. So now we have all the pieces to plug in. We're trying to solve for the speed of the current. How fast is that river pushing you? So we're trying to find for C. We have our distance, we have both of our rates now, and we have our total time. So we have D over R1 plus D over R2 equals our total time. So again, think of it kind of as the portion it took to go one way plus the portion back equals your total amount of hours or time traveled. So plugging in our distance, we go 45 miles one way over rate 1, which is 12 plus c. And then we're going 45 miles back the other way, but this time we're going up the river, so we get 12 minus c, and we did a total of 8 hours of travel. So notice again we have another rational. So whenever we have these lovely rationals, Again, we want to get rid of that fraction by timesing by our LCD. So our LCD, whenever we have two binomials, is just going to be those multiplied together. So 12 plus c times 12 minus c. You can also notice that 12 plus c times 12 minus c is a difference of squares. So if you wanted to, you could write this as 144 minus c squared. Either way would work, but I'm going to keep it in factored form for now. When I FOIL this into all three parts, we're going to get 12c, or 12 plus c, 12 minus c, 12 plus c, 12 minus c, and then this 12 plus c times 12 minus c. I'm going to squish that in there. So on this first fraction, the 12 plus c's cancel, but I still have this 45 times 12 minus c. So I'm going to distribute that through. So 12 times 45 is 540. And then 45 times a negative c is a negative 45c. And then on this fraction, the 12 minus c's cancel. But again, I have that 45 that I need to times into the 12 plus c. So 45 times 12 is another 540. And 45 times positive c is a plus 45c. And then on this one, we have that, again, difference of squares. So you can think of this as 144 minus c squared, or you can FOIL it, but you'll get the same thing. So I'm going to times that 8 through. So 8 times 144 equals 1,152, or again, you could do 8 times 12 is 1152. And then we get 8 times a negative c squared is a negative 8c squared. So the nice thing was over here, we have a negative 45c and a positive 45c. Those are just going to cancel out with each other, which is convenient. And then we have 540 times 5, or plus 540. So we can add those together, which is 1,080. So we just have a number over here. And then that equals 1152 minus 8c squared. So if I'm solving for my current, I want to get c alone. So let's minus this 1152 over to get our numbers together. So if I do 1080 minus 1152, I get negative 72 equals a negative 8c squared. And now solving for c, again, we want to get rid of that negative 8, so we'll divide by negative 8 on each side, which is good because that'll get rid of our negative for us. So negative 72 divided by negative 8 is a positive 9. And then c squared, to get rid of the square, we take the square root. And so we get c equals 3 plus or minus 3. So you can think of your current as being 3 miles per hour. So that's how fast the river or the stream is going. Sometimes they'll just have you say what the current speed is, but sometimes they will say how fast were you traveling downstream or how fast were you going upstream. If that's the case, you might have to take this 3 and plug it in. So like if I plug that in, going downstream, I would do 12 plus c, which is 12 plus 3, which is 15 miles per hour. And going upstream, I would do 12 minus 3, which is 9. So it just depends on the problem, but sometimes they will have you plug it in. But on this one, they just said what was the speed of the current, so we could stop there. So just make sure to always answer the entire question, and don't stop too early. Make sure you're answering what they need. But that is a form of a distance, rate, and time problem. Again, these are ones where you're going somewhere and then coming back again. So hopefully you guys feel okay with that. Again, story problems, I know they're frustrating sometimes, but they are important because that is the whole point of math, is how to apply it to real situations. And it's good for your brain, good exercise for your brain. So if you guys get stuck or need any help, again, as always, please don't hesitate to email me and reach out, and we can set up a Zoom call and I can help you. Hope you guys are doing good and staying healthy. See you later.